Hi, Professor. This is the final week of the course DATA802. And in this week, I'd like to give a presentation on the case study that I did using the time series analysis technique. Okay, first of all, let me begin from the introduction part. So in the previous weeks, we learned about time series data analysis in this course of Data 802. And in this week's assignment, I will comprehensively use an ARIMA model to make forecasts for the future. In the past, actually many scholars published many papers in the literature, and many of them focused on the ARIMA model applications. So ARIMA model is a widely used statistical model in a time series analysis. Next, I'd like to give a small literature review in the literature. So we can see that in the year of 2017, JETHAB set up an ARIMA model to forecast three agricultural products prices. They found that the metrics measuring the model performance was pretty good. So that demonstrated the validity of their forecasts. In the year of 2019, Dai and Chen used an ARIMA model to forecast the population in the Zhejiang province of China. The data ranged from 1978 to 2016. And the result implies the fitting effect was pretty good. And in the year of 1997, Xi established another ARIMA model to make forecasts for the real estate prices in Hong Kong. They found that there was a strong cyclical trend in the office and industrial property prices locally in Hong Kong. So that was the relevant articles using ARIMA model in the literature. In the next section, I'd like to introduce the methodology that I will use for my case study. So the objective of my case study is to forecast the US soybean prices for the next 12 months. This is a pretty important reference for decision making. As for the soybean planters in the United States, based on the forecasted prices in the future, so they can know roughly whether the price will rise or go down, so that they can make plans in advance whether to increase or decrease the scale of their production. The steps of the data analysis is as below. First, I collect the US soybean prices from online. Next, then I will use R to estimate a model. The first step of the analysis is to test the stationarity of the US soybean prices. This is very important as only the stationary price series can be analyzed. So next, if we have found that the price series is not stationary, then we need to take the first order difference of the series and then test the stationarity of the difference the series again to see whether it is stationary. If not, we will make the second order difference again and again until it is stationary. Next step is to draw graphs, calculate and draw graphs of the ACF function and the PACF function of the difference series, so that from the graphs of these two functions, we can determine the orders of the Riemann model that we will use. Then we can set up a Riemann model and use R to estimate the related coefficients of the model. And finally, we can use the estimated model for forecasting the soybean prices in the future. Okay, the next section is the data section. So I collected the soybean prices of the United States from the USDA's website. USDA is the Department of Agriculture of the United States. So in my case study, the time range of the data that I collected is the monthly data, monthly US soybean prices starting from January 2012 up to December 2023. I graphed the US soybean prices series as below, so that we can see starting from January 2012, at first the soybean prices rose up, then peaked, and then kept going down. So starting from about January 2015, it kept decreasing slowly until July 2020. Then it rose again and peaked again and maintained at a relatively high level. So that was a trend of the soybean prices in the United States. In the next section, I will present the R code I use for the analysis and the results that I obtained. So the first step of the analysis is to install some packages used in the modeling. We need to install some packages in R. So these commands will install the corresponding packages in R. Next step is to import the soybean prices data that we need to use into R. I use this command to import the data, and then we can use the head command to check the first few rows of the data set, so that we can have a rough idea of what the data set looks like. Next, I will define the time series. I use this command to define the US soybean prices series as a time series, so that the R system can recognize it as a time series. Okay. The next step is to check the stationarity of this prices series. Generally speaking, we can use an ADF test to test the stationarity. We can use this command for the ADF test and then print the test result. From the test result, we can see that the p-value is 0.8623. It is above the 5% threshold. So we can say that the original series of the US soybean prices is not stationary. Now that the time series is not stationary, the action we should take in the next step is to make a first order difference and then do an ADF test again on the difference time series. So we can use this command in R to to make the first order difference, and then do the ADF test again and print the result of the test. So from this ADF test, we can see that for the difference, the series, the p-value is now 0.01. So it is less than the 5% threshold. Now we can say that the difference, the time series of the U.S. soybean prices is stationary. We can conclude here that we can obtain a stationary U.S. soybean prices series after making the first order difference. Okay, next, we can calculate the ACF and PACF functions of the difference series, which is stationary, and then draw the graphs of the ACF and PACF functions. We use these commands to calculate and plot the functions so that we can see in the ACF graph, we have just one bar sticking out from the threshold. And the PACF also has one bar sticking out from the threshold, so that we can say the orders for the AR part and the MA part of the ARIMA model are both 1. And just because we concluded that after making the first order difference, we can obtain a stationary time series of the prices data, so that the parameters we use in an ARIMA model should be ARIMA 111. So here, the first one means the AR order is 1. The second one means it's the first order difference. The third one means the MA order is also 1. We can use this command in R to estimate this ARIMA model, and then print out the result of the regression, so that we can see this model fits well, and here are the coefficients that we need to use. And finally, now that we have already established the model, in the next step, we can make forecasts for the U.S. soybean prices in the next 12 months. We use this command in R to make forecasts for the next year, and then plot it in a graph, so that we can see this blue line is the forecasted values of the U.S. soybean prices in the next 12 months. Okay, after we have estimated model and making forecasts for the future, we can make some conclusions up to here. So the first conclusion is that we can see from this graph, the forecasted U.S. soybean prices in the future 12 months are relatively flat, and they maintain at a relatively high level of prices, though still lower than the peak. And we can say that this forecasted model is very important for decision making, because it is very critical for the soybean planters in the United States. So once they have obtained the forecasted soybean prices in the future, this can guide their actions in the future 12 months. So if they expect the soybean prices will go up in the next 12 months, they can make plans to increase the production of their soybean. But if they expect the soybean prices to go down in the next 12 months, then they can reduce the production scale of their soybean so that we can avoid losses in the future. Okay, so this is pretty much what I have presented for today. Thank you.